Hi, today we will learn how to calculate position vector of the foot of the perpendicular drawn from a point to a line. For this purpose, we have chosen a question from past papers of A-levels P3, and this is from 2025 paper, and it is question number 9 of May-June session. So let us start. So what is the statement of the question? So in the statement of the question, they have given us position vectors of 3 points A, B, and C. And they want us to calculate the position, the direction, the vector equation of the line passing through point B and C. So in the A part, we need to calculate the vector equation of line L, while in the B part, we need to calculate position vector P of the foot of the perpendicular drawn from point A to the line L. And finally, in the C part, we need to calculate position vector of D, which is a reflection of point A in line L. So let us start. So first of all, we need to calculate the vector equation of a line through B and C. For that purpose, first of all, we will calculate the direction vector BC. So it will be calculated using the position vector rule. BC equals to OC minus OB. Since both OC and OB are given, so we easily calculate vector BC. Now the vector equation of the line is R equals to A plus TP, where A is the given point and P is the direction vector. So we will take B as our given point and we will take vector BC as our direction vector. So we will simply plug in the values of vector OB and vector BC, and hence we will get the vector equation of the line L. Now in the second part, we need to calculate the foot of the perpendicular drawn from point A to the line L. So in this diagram, you can see I have drawn for you the line L. And from A, we have drawn a perpendicular, and the foot of the perpendicular is denoted by point B. So we need to calculate position vector of this point P. So to find the position vector of point P, first of all, we will calculate a unit vector in the direction of line L. Since the direction vector of line L was BC, so we will calculate unit vector BC by dividing the vector BC with its magnitude. So you can see that unit vector U is 1 upon root of 42 times 1 minus 4, 5. Now in the second step, we will find the length BP, and to calculate the length BP, first of all, we will calculate the vector BA. So vector BA will be equals to OA minus OB. And since both B and A are given, so we can easily compute vector BA. Now to calculate the length BP, we will take the dot product of vector U and vector BA. So you can see that in the dot product, we multiply X component with the X component, Y component with the Y component, and similarly the Z component with the Z component, and then we add the three products to get the dot product. And you can see that the dot product is root of 14 upon 3, which means the length of BP is equals to root of 14 by 3. Now, how can we calculate the position vector of point P? So for that purpose, we will use the vector equation in a different manner. So this time you can see that I wrote the vector equation R equals to A plus parameter time the unit vector. So if in the place of the direction vector, we use the unit vector U, then what happens that if T is 0, we get the position vector of A. And if T is equal to the length of BP, it will give us the position vector of point P. So you can see that what I have done, that in place of U, I placed vector U, that is the unit vector, and in place of T, I placed 14 root of 14 upon 3, which is basically the length of BP. And hence we got a vector which is basically position vector of point P. So that was the second part of the question, which was a bit tricky, but I think now you can do this question. Now for the third part, we need to calculate the position vector of D, which is reflection of point A in the line L. So you can see in this diagram, I have drawn for you the point D. Now to find the coordinates X, Y, and Z, how we will proceed? First of all, we will calculate vector AP. Now, we calculated P in the B part of this question, so we can calculate vector AP from OP minus OA. OA is already given and OP we calculated in B part, hence we can easily compute vector AP. Now, after calculating vector AP, since D is the reflection of AP, therefore length AP and length BD are equal. Therefore, we can write that vector AD is twice of vector AP. So therefore, we will write vector AD is equals to twice of vector AP, and we can simply compute vector AD. Now, finally, to compute the position vector of D, we will use the triangle law, that is vector OD equals to vector OA plus AD. We already know OA from the statement of the question, and for AD, we can use this value, and hence we will add the two column vectors, and finally, we can get the position vector of D. So that was all from my side. We'll see you in the next video with another concept. Till then, take care.